Kia ora Year 11 and Year 12. I'm going to start doing some AS holiday revision videos of both the Pure 1 papers and the Stats 1 papers. So I'm juggling my time between A-level revision and this, so please do let me know if you're watching this and if it's helping, if it's about the right pace. They're going to be done reasonably quickly. If you find any mistakes, I'm sure you'll let me know. So I'm going to stick with one question per video. This first one is a binomial expansion, but an AS level binomial expansion. And the first thing we have to figure out is that we're told we've got a term independent of x in this expansion, right? And the value of that term is 540. So our job here is to work out what is the value of k. So k is the constant in here. Once we've found that, we have to go back and find another term in that expansion and find the coefficient of that one. So the way that I do these is I just start by writing out the binomial expansion, and I look for patterns in the powers of x. So with this one here, the first term is going to be 2x to the power of 6. Now, I don't bother expanding at this point because that's a bit of a waste of time. The next term is going to be 6 choose 1 times 2 to the x to the power of 5 times k over x to the power of 1. So if I look here, this one has got x to the power of 6, and this one has got x to the power of 4. So I want the term that's independent. I know I'm going to have to go a couple of terms further on. I can see that there's a weird cursor thing turned up on my stylus, and I don't know how that's happened. I think I blame the author of Teresa Talks Logs for that, but never mind. So you're just going to have to put up with that, sorry. Right, so look, we've got to the term that we want. We've found the one that is independent of x. It's going to be this one here. Now I can see that because I've got x cubed here, and then I've got x being cubed here. So they're going to cancel out. So what we want to do now is work on this term and set it equal to 0. Sorry, not to 0, to 540. So we've got 6 choose 3. I know you're going to do that on your calculator, but I'm just going to remind you what a combination looks like. So this times 8x cubed times k cubed over x cubed is equal to 540. So the combination simplifies to give me 6 times 5 times 4 over 3 times 2. So again, I know you're calculating that, but that's going to be 20. So 20 times 8 k cubed is equal to 540. That gives me 160 k cubed equals 540, leaving me with k cubed is 54 on 16, which looks like 27 on 8. And as soon as I get to that point, I should feel pretty happy that I haven't mucked it up, because both the 27 and the 8 are cube numbers. So k is equal to 3 over 2. So that's the first few marks done. Now going back to the question, what do we have to do? Well, for this value of k, find the coefficient of x squared in the expansion. So we've actually got that written out here already. It's this one here, right? You can see that it's got an x to the power of 4 here and an x squared. So we're now going to clean that up. And we have 6 choose 2 times, I've got to remember what it was. Hang on. So 6 choose 2 times 2x to the power of 4 over k on x. So that's 3 over 2x squared. And we want to work out what that is. Well, 6 choose 2 is 15. So it's 15 times 16 times 9 over 4x squared. And that works out to be 540x squared. So my coefficient is 540. I'm just going to quickly go over how we did that to wrap it up. So the first thing we did when we had the binomial expansion question is we wrote out the first few terms. Right? So we looked at this and we just followed the pattern. Now I'm following the pattern exactly as it is on the formula sheet, so you don't have to remember this one. A-level people, remember, it is different from what we do in A-level, where we've got negative and fractional powers. And I'm looking for the independent term. So the way to do that quickly is to go, okay, this one's x to the power of 6, this one's x to the power of 4. They're going down, they're bumping down in 2s, so we're going to end up with 2 more terms till we get what we want. And to find k, we just work out the coefficient, and then we use that coefficient and chuck it back into another term. And that's quite a common problem pattern for straightforward binomial questions. Thanks for watching. I'm going to do one about a tangent and a curve in a minute.